All right, so I made this one up. According to a random made-up study, that's me, 70% of college graduates felt that their statistics courses would be useful in their careers. Suppose this result was true of all college graduates at that time. Okay, we're going to suppose it's true of the population. In a recent sample of 3,000 college graduates, 74% said their statistics courses were useful. Is there significant evidence at a 5% significance level to conclude that the current percentage of all college graduates who will say statistics is useful is different from 70%? Use P and critical value. Okay, so first of all, this is a proportion because you're given a percentage, so you're using Z. Okay, so we will use Z here. Now, let's see what we have. So we have a proportion, you have a P is 70%, so that's 0.70, which means your Q, so the percentage you said it wasn't useful, 30%. We did a sample of 3,000, that is your sample size. Okay, and inside that sample, 74% said it was useful, that's your P hat. Okay, your proportion inside the sample. Okay, is there significant evidence at 5% significance level? So your significance level is 0.05. Okay, and then here's what we need to know. We need to know what kind of test are we doing. So we have to state our null hypothesis and our alternative hypothesis. So our null hypothesis is that P is, let's see the question. Is there significance level to conclude that it is different? Okay, so when it's different, it doesn't say less than or greater than, so this is a two-tailed test. That the P is equal to 0.70, and then the alternative hypothesis is that P is not equal because it's different than that. Okay, notice it doesn't give you a range, so it's just, is it that or is it not? Okay, when you have a not equal to, that is a two-tailed test. So to get our Z value, we're going to take the significance level, we're going to divide it by 2. Okay, so 0.05 divided by 2 gives us 0.025. Okay, then we need the Z value that gives you 0.025 in either side of the tail. So we're going to take the tail. Okay, we have the area, so we use the command inverse norm. We want the area to the left, so 0.025. We have standardized the scores. We're using 0 for a mean, 1 for a standard deviation. Okay, so second distribution, inverse norm, 0.025, 0, and 1. So negative 1.96. It's two-tailed, so I'm using plus or minus 1.96. So we're going roughly here and here. Okay, meaning these are my rejection regions. Okay, so to the left of 1.96 and to the right of 1.96. Okay, so let's go ahead and get our Z value. So our Z value is going to be given by P hat minus P over the standard deviation of P hat. Standard deviation of P hat, not P bar, sorry, P hat, is given to us by the square root of PQ over N. So we are going to do the square root of 0.7 times 0.3, P and Q, sample of 3,000, so over 3,000. So square root 0.7 times 0.3, close the numerator, divided by 3,000, close the square root, we get 0.0084. Okay, so that is your denominator. And then you have P hat is 0.74, P is 0.7, so 0.74 minus 0.7 divided by 0.0084 gives us a Z of 4.76. Okay, where is 4.76? Okay, that's your observed Z. That's way over here. So this is definitely in the rejection region. So we will reject the null. Okay, we will reject the null that the true proportion of people who say statistics is useful is not 70% people. Okay, it is either less than that or greater than that. And then since it was 74% in this large sample that is completely made up, we should conclude that it should be more than that. So statistics is significantly useful to your careers. Okay, and then if we use a p-value approach, you want to get the p for that. That p is probably going to be 0. Okay, remember your p would be normal CDF. And then it would be 4.76 for your lower limit, positive 99 for your upper limit. So second distribution, normal CDF, 4.76, 99. Yeah, so that's 0 because it's 6 zeros and then a 9. So p is 0. Alpha, 0.025. And p is less than alpha, so we reject the null.